In our last video, we showed you how to test analog cameras, even using headphones, which is a great little hack when you don't have a test monitor handy. In today's video, we're going to step it up and look at how to test IP cameras. So, if you have an IP camera that's acting up and you want to troubleshoot it, just follow the steps we're about to show you, and you'll be able to get it sorted out. If you missed our previous video on analog cameras, don't worry. We'll link it for you at the end of this one. Alright, for this test, you'll need the camera you want to check. We're using this specific model as an example today, but the process we're covering works for pretty much any IP camera out there. This one here is a Wi-Fi camera, but it also features a wired Ethernet connection. It has a power input for a 12-volt supply, and like most IP cameras, it includes a reset button to restore it to factory settings. Besides the camera, we're going to need a power adapter. Most of these cameras run on a 12-volt DC supply with at least 1 amp, usually with a center positive connector. If you don't have a spare adapter lying around, take a look at other devices in your home. Things like routers, modems, or TV receivers often use power supplies that are compatible with these cameras. Just a quick heads up, before you plug anything in, double-check that the adapter is 100% compatible with your camera's specs. If you're unsure about compatibility, feel free to leave a comment below or reach out to our free support via WhatsApp. We're happy to help you out. All we ask in return for the assistance is that you subscribe to the channel and like this video. It really helps us keep this free support service running. You can find our contact info in the video description and in the pinned comment. Once you have everything ready, the test is quite simple. But before we power it up, if your camera has a memory card installed, we recommend removing it. In our example camera, the memory card is located inside, so we need to open this compartment to get to it. However, on many other models, the slot is exposed and very easy to access. After removing the card, we're going to close the camera back up so the cover doesn't get in our way. Now, the next step is to connect the power supply to the camera to boot it up. Some cameras will provide voice prompts or audio instructions once the system initializes.
Please configure camera by AP hotspot or scanning code.
If your camera talks to you, that's a very good sign that it's likely functioning. Regardless of audio, you should test the night vision. You can cover the light sensor to see if the infrared LEDs turn on. Our camera here is in a low-light environment with high sensitivity, so the LEDs kicked in automatically. Usually, though, you'll need to cover the sensor. If you're not sure where the sensor is, just take the camera into a dark room. You should see a faint red glow coming from the LEDs. If you can't see any light with your bare eyes, try looking through your phone's camera. But some iPhones have filters that block this type of light, so it's best to check using an Android device or another phone without those restrictions. If the LEDs don't light up, the camera might be defective. In that case, double-check that your power supply is actually working. However, even if the power supply is fine and the LEDs still don't turn on, you should still proceed with the rest of our tests. It's entirely possible that only the infrared board is faulty, while the rest of the camera's hardware is functioning perfectly. If the LEDs do turn on, listen for a clicking sound when they toggle. That noise is the IR cut filter moving. When you hear that click, it means the main board is likely healthy. However, some IP cameras have settings that disable this filter, so even if you don't hear sound, we'll move on to the next test. The next step is connecting the camera directly to a computer to check the network stage. Plug an Ethernet cable directly between the camera and your PC. If your computer is currently connected to a router, unplug that cable and swap it for the camera's cable. Next, open a program called ONVIF Device Manager. This tool allows us to identify the camera on the network. If you don't have it, you can easily find it for download online. With this software, we can easily find the camera's IP address. Once we have that, we can configure our computer's network settings to match, allowing us to log into the camera. If you can access the interface, the camera is perfectly fine. In that case, if you're still having trouble viewing it on your phone or NVR, it's likely just a configuration issue. But keep in mind that ONVIF Device Manager only works if the camera supports the ONVIF protocol. Most modern cameras do, but some have it disabled by default. Alternatively, you can use the manufacturer's official software. Our example camera uses a program called NVClient, which communicates using its native protocol. This works even if ONVIF is turned off. If you're not sure which software your camera uses, check the manual or the manufacturer's website. As we mentioned earlier, if you need a hand with any of this, just leave a comment or contact our free support team. Don't forget to subscribe, and if you have a specific tutorial you'd like to see, send us your suggestions on WhatsApp. You should see a button on your screen now leading to our video on testing analog cameras. Just click or tap there to watch. God bless you, and we'll see you in the next video.